All right, so I think we should get started. Thank you everyone for coming today. And this is a really full house today. And thank you, Elizabeth. What a great way to start the session. Now I feel like we know everyone, so we're very let's have a very frank conversation. So we have four session organizers. Myself, I'm Binita Kisi. I'm with Justice. We have our lovely Elizabeth Joyner here. We have Mukul from Applied Sciences, NASA Applied Sciences, and Jong also from NASA Justice. So we will coordinate all these sessions session here. So hopefully it will be smooth. So this is our agenda for the day for this session. First, we will start with introduction. We'll spend 10 minutes, and Elizabeth and I will be giving a brief introduction about the session and how we want to proceed with all this interactive question answer Q&A session. And we have four invited presentations, and each presenter has 15 minutes to present, and we'll take all the questions at the end. And we will use Mentimeter today to get your feedback throughout this session for each of the presentations. So Elizabeth is going to share the results, summarize those feedback at the end after each of the presentations, and she will spend 10 minutes. And finally, we'll do Q&A and discussion, and Jong and Mukul will be leading that. So I would also like to welcome those that are online, and we have one speaker who is giving a virtual presentation virtually, Daniel Tong. I also saw him online. So, all right. So this is the outcome and goal of our presentation, of our session. Would like to identify or access data needs from interdisciplinary users. We'd also like to identify significant gaps and would like to come up with some collaboration with interagency and partners on the tools that have been developed to serve the interdisciplinary users. And this is the order of our presentation. So first, it would be Susan Singledaker. Everybody knows Susan here, so she doesn't need any introduction. And the second speaker is Sudhir Rasresta. He's from NOAA Water Center. And third speaker is Michael Humber. He's here too. And the last presenter is Daniel Tong. He's joining us again virtually. All right, so we have meeting notes. So make sure to scan this QR code, and it will lead you to the our meeting note document. So if you have any questions, you can feel free to put that in that meeting note document as well as online. And we'll be taking notes as we progress throughout this session. And make sure to get in that document and make sure to check in. So so that we can contact you later if we need to. All right. So Elizabeth, now she's going to talk about the Mentimeter and how we want to.
All right. Hello again. So Mentimeter is the only software for polling that's on the NASA approved list. So if you are familiar with Slido and others, I am so sorry for you. Mentimeter is the one and only that we are going to use. We're also going to leverage Mentimeter for questions and answers. So for you online folks, they're used to Kiko Chat and others. Please use the Mentimeter for that as well. We have Chat and Teddy online. She's going to be monitoring that. And thank you so much, Teddy, for being our online host. And Chad's going to be monitoring that here in the room. Thank you so much, Career Changer Chad. And so at this time, this QR code points us to the polls where we're going to be inquiring about who you are, what kind of data user you are, how and where you access data from, and also the way today's going to work is that we have four presenters that Benita mentioned, and in between those presenters, we have two separate questions that we're asking, and these are in the form of word clouds. And most of us are probably familiar with word clouds. This word cloud is actually, it's the same word cloud for the whole day, for the whole session today. So and I'm going to go through that in a second. So you should be able to access those 2 questions throughout the whole day today. And let me give this a go. Give me 1 second. We're going to actually try this out, try out the poll. We're going to model this together, your access to the Mentimeter, by telling you a bit about a dinner plan that we have. So this interdisciplinary community needs working group that Benita, McCool, and Zong and Irina and some of us attend, we're getting together. So if you think we're a fun group, well, guess what? We kind of are. And if you want to hang out with us Thursday at 6 o'clock, we're going to go to the Windjammer restaurant. Kim Locke over there, she snuck in and didn't do the fun thing that we did. Kim, raise your hand from Applied. Actually not applied, from EIS, NASA. She does a lot of stuff. She recommended the Windjammer restaurant. She says it's within a short walking distance. I'm going to see who is interested in joining us. You are welcome to join. And we have a question in our chat about this. And so give me a second. Now, of course, I put this Mentimeter together, so I should know how to work this, but okay, give me a second. I'm gonna keep navigating through that. And I'm going to, all right. Will you join us? If yes, please add your name. So this is one of the questions you should be able to navigate to. If you have a friend or a loved one that has joined you in this beautiful city of Burlington that you like Kim or Bob, if you want Bob to join, you're welcome to. Just add a +1, but this is something that you're welcome to join. We thought that we would extend this invite. So I don't see any takers. That's okay. But we do have reservations, and I would need to know by the end of this session if you're interested in joining. So now come on, people. It comes at the end. You're exactly right. I should have put it early. I'm so sorry. So if that's a little confusing, you just go to next. Aretha Shruti says, so just go to the end of this poll. I should have put it at the beginning. I do apologize. Go to the end next if you want to join, but you'll be able to go back to navigate back and forth in this poll. All right. Does that work for you? Thank you for testing this.
Yeah. For me, it just shows the question, like the first question, and you have to submit to get to the next question.
Yeah, looks like we have to submit the response to get to the last question. Probably we'll do it and then
We'll do it at the end. So don't do it yet. We'll do it at the end. My bad. Okay. So as my kids say, right? All right. So Wendy, yay for Wendy. All right. We appreciate whoever said yes. We do need your name and we will come back to that. All right. So let's go back. There's anytime you try new things, this is what you get. All right. So let's take a look. I want to show you that I see we've already got some interesting input into question 1. As our presenters present, we're going to want to hear from you what problems or pain points exist for interdisciplinary users of earth science data that present themselves in these presentations. Some of you have already entered that information. Another question will be, now just hold off and maybe just hold off in putting your comments in here until you hear of what they suggest. What solutions do you observe or recommend to meet users' needs represented in the speaker's presentations? So you will enter those in. Now you only have you have a limit of 10 inputs total. So just hold off on those. But so after each presenter, you're going to come back to that same word cloud and enter those data in. I know it's a little tricky, but hopefully this will make sense. So I will remind you at the end of the presentations to come back in to question A and question B if you haven't already used all of your 10 inputs. And that's okay if you already have, that's all right. And we'll go ahead and get started. All right. So without further ado, we have Susan Shingledecker, and she is the wonderful leader of ESIP. We've heard from her just a few times, and we're going to hear from her again. Thank you for joining us.
Thank you, Elizabeth. Wow, so many people in the room. I love standing room only, and I love an ESIP session where Elizabeth is like, wow, it's 15 minutes before the session and we've got all these people and we should get to know each other. And I just love that that's the spirit of this community. How do I advance?
Yep, you can use
This one?
Yeah.
Okay. So I'm excited to have the opportunity to share with you a little bit about some work that ESIP has done with NASA on a program called Unbound. Unbound is one of my favorite acronyms, actually. It is understanding user needs to broaden the outside use of NASA data. Like, what a great acronym. It actually really says what we're trying to do with that. So ESIP was asked to run 2 series of workshops with user groups who are not currently using NASA data, or maybe they're using it just a little bit, right? And get their feedback about when they go into NASA data systems, what is their experience like? What are their struggles? What are their challenges? And then we were to provide very specific feedback back to NASA on things that could improve people's ability to access their data and tools. And we were to put the feedback in, change the color or the link or put this wording here, very small, discrete, easy, actionable feedback, all the way to, we don't have the resolution we need, launch another satellite, right? And things that could be done tomorrow. And we've actually seen that happen, to things that would require literally, probably acts of Congress to make happen. So the first one we did was we engaged environmental justice stakeholder groups. And I presented on that work in Pittsburgh, and we have that report online for those of you that were interested. That was the single hardest workshop series I have ever run. We were taking a group of environmental justice organizations. And for those of you that know, small community-based nonprofit organizations that are trying to do amazing work in the world usually don't have data scientists on staff, right? They are working in Excel, they're cobbling together what they can, and they found NASA data resources really intimidating. So our second workshop series, we were working with air quality stakeholder groups. And we really worked hard in our participant recruitment to really screen for, okay, you've got to have someone on your staff that can manage and manipulate and work with data. And so we definitely had a more elevated expertise within the group of people that we worked with. Now, it's important to be clear, we were not training them. This was not training. There are other parts of NASA that do that. We were extracting feedback from them for NASA's benefit, to make the products better. Was there a co-benefit? Did they learn a little bit? Did they improve their skills? Did they become aware of things? Yes, but it was very important to me that we stipended these participants for their time and their involvement. So most of our budget actually went to some outside facilitators, because ESIP is only a staff of 5, and to stipends for our participants. And so I just like to point that out when you are getting user feedback and when you are engaging user groups. Is the benefit for them or is the benefit for you? And if the benefit is for you, you really need to pay them for their time, especially if you're working with small community-based organizations. So we engaged, some of you may know, we engaged Kelsey Briesman from Environmental Data Governance Initiative, and we engaged the wonderful Charlie Haley to help us be a force multiplier. And they did a fantastic job of designing this workshop series for us. We had 3 different workshops where we aimed to go a little bit deeper each time we met with the group that we were working with. So the first one focused on data discovery. What did they find challenging about finding the air quality data that they wanted to use? Our second workshop, which was just 5 days later, we had asked them in the intervening time, we said, okay, based on your research questions, based on what you are trying to achieve, our friends at NASA have identified a few data sets that might work for you. Now you don't have to find it, because that was kind of hard for some of them. Here's some data sets, go get them, go download them, and come back, and we're going to talk about how that worked. And then we're going to dig a little deeper. And then the third workshop, we kind of set them off to work on their own. on their own specific questions. We brought more NASA experts into the room to help guide them. I think that was the one that was the day, one of these was unfortunately the day that Tempo launched. And so that was a crazy little, couldn't plan for that, but it was, so this was kind of the design and the structure that we used to get the feedback from these users. I apologize for the blurriness, but this is the list of the groups that we engaged. We probably had, I'm not remembering exactly, we probably have 50 to 60 organizations apply to be part of this workshop series, and we selected 12. Most of these are people, like I said, that aren't using NASA data regularly or at all. That is a challenge, right? These are people that they're not going to be able to just jump in and run with it. You have to open the door for them. You have to show them how to get inside a little bit. You can see on here, we had a few universities. So, not all researchers know exactly where to go. We had a lot of community groups. You can see that we had some large environmental organizations like Environmental Defense Fund and Earth Justice. And then we had some really small environmental organizations like Concerned Citizens of Cook County. We had 2 state agencies, the New York State Department of Environmental Conservation, and TCEQ is Texas Council of Environmental Quality. We had a Thriving Earth Exchange project from AGU. So really great group of people. And we allowed each organization to bring more than one person, right? Because this is hard work. And sometimes it was helpful for them to have a peer to be a sounding board and to do the work with them. So for that first findability workshop, we told them exactly what we wanted them to go find. Maybe they weren't in Texas, maybe they didn't care about the year 2011, but we wanted to have, we said, go find this, ready, go. And watched what they did. The way we structured it in the rooms, they were in breakout rooms. This was all virtual, it was on Zoom. We had one driver. So that was the person sitting at the computer. They couldn't talk. They just had to follow the directions that were given to them. We had 1 or 2 researchers or navigators. So these were the people that were giving the directions to the driver. Okay, so let's start with Google. Okay, type in this. One group said, well, they gave us Earth data logins. So we kind of led the witness a little there, but we needed to get them, we need to make sure they could get into Earth data. So go there. What was interesting about the navigator driver combination is that oftentimes we do things, there are things in our heads that we're thinking, but somebody watching us wouldn't know what we're thinking. So you would hear them say, okay, click on that. No, don't click on that. Click on this. Oh, that didn't do what I thought it was going to do. And so we got really great quotes and feedback when we could see what they were thinking. And that was Kelsey's experience with user design and user interface work. And it was brilliant. And then we had one person taking notes and documenting what they were finding. So what we found out through them, so that was the first workshop. The second workshop, they downloaded their own data. And similarly, we got to hear where their pain points were. Were they able to download the data sets we told them to download? And we used that driver navigator model through most of it, except for the last session. And we tried to graph what they told us. Stinger, this is all in the report. Oh, you're taking a picture of me. So this is the data formats. Data formats were something that really came up as something that was challenging, right? They would get the data set, but it was maybe in a format that they didn't know what to do with, right? And so one of our recommendations is using common data formats. And so we said, okay, well, what one format that someone's comfortable with is different than what someone else is comfortable with. So tell us what formats you are ideal versus acceptable. And this was the responses that we got for that. It's now not advancing though. Oh, shoot.
Oh, gosh. I'm sorry.
I got it. Thank you.
Sorry.
Another thing that we saw, they were working in groups, like I said, in these breakout rooms, but not everyone had comfort and familiarity with the same tools, right? And so we wanted to know what tools would you want to use? We downloaded the data set and then they were trying to open it. What are you going to use? Where do you want to go with this? And so we ask them, what tools you use, can you use it, or can you really use it, right? My work currently uses this tool, or I can use this tool, right? Especially with the small organizations, it was interesting. A lot of them actually could use ArcGIS because they work for a nonprofit organization and Esri donated licenses to them. So it was actually really accessible to them, but that wouldn't be the case for everyone, right? We had some situations where formats, people didn't know what to do with them. And Kelsey said, okay, just on a whim, go into ChatGPT and ask ChatGPT how to open that type of a file. And so they really played around and were very curious and very, very exploratory. And then we wanted to see, were they able to achieve what they were looking to do? So this was for that first workshop where we said, go find the PM 2.5 in Texas at this resolution in 2011, right? So were they able to identify the appropriate data set for their needs in terms of date and location? Not very well. Date and location was hard for them. Were they able to identify an appropriate data set in terms of the resolution? I think it was the 1 kilometer. A little bit better. Were they able to identify an appropriate data set in terms of PM 2.5, right? So they were able to get PM 2.5, maybe in the right resolution, but we struggled on getting the right date and the right location. And then I think it's for Texas was what we were looking for. Then we also looked at, their ability to achieve their objectives in other ways. So were they able to identify and load the data format that was provided? Okay, so we did all right there. Did they find that the data was clearly documented so that the columns were clear? No. Struggled massively there. Are the data limitations clear? No. And were they able to create data explorations? Were they able to create graphs and maps and were they able to work with it? And, we had one group out of 5 that was successful there. So these groups struggled and they worked through that and we documented all of their findings. The great news was that this group of people who really were not NASA data users after the workshop, 92% were more likely to use NASA data. The about the same was probably a person that was already using it somewhat, I would guess. All of our findings are in a report that was given to NASA. I have to say the NASA staff were incredible. If anything, HeyCast and Elizabeth with Data Pathfinders, everybody was so eager to be in there and listen and hear. But one of the findings we had to balance was the participants were a little bit intimidated when the experts were in the room. And here at ESIP, I know you guys are all approachable, but they're like, oh my gosh, it's the NASA scientists. They're really smart, right? And so we wanted to balance getting the honest feedback with giving them a safe space to say they were struggling with providing them access to the people who could help answer their questions. And I was talking with Pam from Applied Sciences last night, and I was like, I would love to transition these people into some kind of a workshop for more training because they're very eager. So these were our 5 core recommendations to NASA. I don't think any of these will surprise any of you. Obviously, we have much, much more specific recommendations in the report, but I can't put all that text on a slide and I won't do that to you. But reducing the technical skill requirements for access and use, reducing the hardware and internet requirements. Oh my gosh, the number of times we heard someone say, okay, there's the button to download. I'm terrified to click the button to download. I don't know how, I've just got kind of a crummy laptop that's 5 years old from my nonprofit organization. I don't know how big this is. And is it going to just kill my system, right? There was fear. There was actual fear to download the data. And then we talked a little bit about standard and familiar formats, making metadata available, especially before download. So they understand what's going to happen when they click it. And then make data available in standard libraries, right? Not everybody knows what data NASA has, but maybe they are using other places where there are kind of aggregators of data. And I know that gets challenging in terms of duplication, but there's another recommendation that they had. And I'm done. I have my timer going here all
Oh
along,
my
girl.
gosh.
Thank you.
Susan is such a boss. I just want to say, we love her. Susan, there are several questions in the Q&A and Mentimeter that have been posted. So check those out. And thank you so much, Teddy, for keeping me posted about those. They may be working as a back channel for those that are here in the room or virtually. So we'd like to go ahead and tee up the next presentation. In the interim, as we are gearing up for that, go ahead and return to those questions A and B in the Mentimeter. And if you're not sure about how to access that, I do want to remind you that at the top of the screen, does this follow with me? At the top, I'm a wiggler. At the top of the screen, it says join at menti.com and use code, you can see it here, 6905392. That's the code you can put in to menti.com. I sound like a commercial. All right. All right, I will jump off.
All right, thank you. Our next speaker is Dr. Sudhir Shrestha. He's currently serving as a technical manager for NWS Office of Water Prediction, Web and Data Services program, and he's also serves as a key technical support for hydrologic visualization and inundation service HydroVis project involving cloud deployment of national water model and river forecast center forecast visualization. He also works with Office of Science and Technology Policy, the White House, to support an interagency effort on Year of Open Science as a co-chair. And with that, I would like to welcome Dr. Sudhir Shrestha.
Down here.
Stop share and we need to share.
I know. Because then you're sharing. Okay, can you go to the presentation mode? Then you're, so you have to share the,
Speaker mode. Is there?
is this the one shared?
Yep.
Just checking the time. So, good morning, everyone. And thanks for taking time, and definitely would like to thank Vinita for the invitations. It's great to know you all, and it seems like it's house full today. Wow, I'm excited. All right. So I'll be talking briefly about some of the effort that we're doing on the hydrologic data program.
This screen is not being shared. Give
That's
me
right.
one-
Yeah,
one
that's what I was
moment. Let me fix this.
I think she shared the other ones. I think. I think. We're good. All right. Thank you. So I'll talk briefly about some of the modernizing effort that we're doing in the hydrologic data dissemination in our Office of Water Predictions. There are a lot going on. I'll try to rush through, but definitely this is also a collaborative effort. I'm looking forward to get some of the feedback from us. And how do I? No, it's not. Oh, okay. So just to go briefly, I'll talk about some of the effort that we're doing on migrating our AHAPs. So AHAPs mean nothing, a lot of you, right? So just to, these are one of the acronyms in government, right? That we know there are several acronyms that I started to learn when I went to work for government. So AHAPs is the Advanced Hydrologic Prediction Service. So this is our existing hydrological data dissemination platform. And we're actually migrating that into the new platform that's we're calling it National Water Prediction Service. I'll talk about it a little bit about, and that's where we're doing our moving all of our solutions from our on-prem to the cloud. And some of the key features and functionalities and some of the interoperable data delivery mechanism, how we're trying to do right now, moving from XML to APIs, right? And then some of the data services. We'll share some of our current development and what some of the collaborative effort that we're doing. So just to give you a quick on migration of the advanced hydrologic prediction service we call AHAPS to the cloud. Almost like for more than like 2 decades, National Weather Service has delivered water resources forecast products and services through advanced hydrologic prediction service. So this is sort of our legacy service, which has been highly used by our weather forecast community. And this legacy system was developed and sort of like a now like old technology and infrastructure that really needed to modernize to support our newer innovation, technology, and service driven architecture. So that's the reason we know we couldn't just move again, like, because this is a legacy system, the code that's been written on the period of 15 years of time. So we couldn't just lift and shift, right? So we just had to do the whole rewrite of the code base, moving to AHAPS into the cloud. So a total rewrite of this code was done to take advantage. All of you know here that to take advantage of the modern tools and standards that include security, right? Security is important, all of us, for those in the government as well. So we needed to make sure our infrastructure is guided by high uptime. So high uptime is a very important factor for us because we are supporting the operational systems, right? Because so we wanted to make sure our system is up and failover options we have available so that, and then the cloud sort of provided that capability by deployment of different. So what we are doing to do that by deploying into in Amazon AWS different regions and availability zones for the failover and patching. So what you're seeing here on the left, so these are the forecast on that you see in the AHAPS and some of the hydrographs that you see here. So, but incredibly, as you know, in government, we have many ways to deliver the information to the public. Right now, you see we have advanced AHAPS, that's a water.weather.gov, another our water.noaa.gov, that's the Office of Water Predictions. And also we, in the meantime, we also are making our information available through the experimental products to the weather.gov-OWP, right? So to mitigate all these three dissemination effort, we're bringing all these three into the single platform, and that's what we're calling National Water Prediction Service. So this is basically a new, I like to call it like a next generation gateway to the water resource forecast and information on the web. So this future leaning dissemination platform basically transforms how we disseminate hydrologic information to the public and partners so far. So this NWS project basically involves deep collaboration and detailed feedback that we receive from our customers. So this is something we're working with our partners and stakeholders that helped us to actually complete rewrite of the AHAPS web functionality into this modern, efficient, and mobile-friendly web platform. One thing to note here, most of our website right now is not really mobile-friendly, right? But now if you see, a lot of the users, they always want to use their phone, right? Because you want to check your weather here, right? You don't want to go open your computer and do that. So we wanted to make sure our information is web and mobile friendly, right? So whenever you get our information, the information get optimized based on your resolution of your phone. So that's one of our sort of like a priority in that. So basically this web delivery platform is also going to the primary source of our weather service, our water data and forecast information. So basically combines all these three information in that. So, and this is sort of like a sneak peek of what the National Water Prediction Service will look like. And so this is still in the development right now. And we're expected to go live early next year, expected around like January, February. So this is coming and we're very excited about it. So in this one, we're working very closely with some of our partners. The primary user for us is also our NOAA, right? So those are our river forecast centers, our weather forecast offices, but we also work very closely with the USGS as well as the Army Corps of Engineers and FEMA, right? So there are several functionalities. So this is what our National Water Predictions looks like. There are several functionality and enhancements integrated in NWPS. Some of them is a mobile optimized, like I said. and modern data dissemination via API, right? So what we are doing here is basically what you're seeing in the page is basically fueled through our API. So all the data sets are on the back end, we're pushing into the API, and that the API is actually fueling our web dissemination platform as well. So what we have done, we have enabled, one of the interesting capability that I see is we have enabled cross-referencing of gauges, right? So, what is like a lot of we do not have enough river gauges and the forecast locations, right? So what we do now is like, we're trying to have the national water model forecast coming that basically gives you the information around where you do not have ungauged locations, right? So that's something we're trying to look at, but also you can actually cross-reference those as well. Just a quick sort of system architecture of this is something our National Water Protection Service that we migrated to the cloud, right? So basically it was originally developed, just to give you a little bit of story behind, is like, this was originally developed to actually get deployed into our internal on-prem architecture, but the architecture didn't support pretty well. So we decided to go move to the cloud, right? So, but moving to the cloud, what it did was basically, ease of the deployment, everybody aware of that, right? Flexibility of feature development that we can do, short run time to make the data and the solution available. But important is also like a scalability to handle increased usage and demand, right? Because increased integration with other Office of Water Protection Services, that is also important. But front end web and API is auto scaling based on the a user load, right? Especially like during spring flood, hurricane demand, etc. Our demand for the usage goes really high. So this system will be auto scale, and for that we're actually using AWS Fargate for that. And also for the database side, we're using the Postgres database auto scaling as well in the back end that uses the AWS Aurora. So back end process auto scales to make sure that our processing thresholds are achieved during the heavy processing periods. Just a quick snap about API. I do not want to go over here, but what we're trying to do is right now, we're trying to make sure that the API is built on the open specs, right? So we're using open API specs. Right now we're in the version 2.0, but we're in the process of upgrading to 3.9 right now. So talk a little bit about some of the other efforts we're doing how to make our data available as well. So within the web and data program, we have the web dissemination component that I talked about, but I also in my team, we also work on the data and service program as well, which we're trying to do to expand some of our capabilities through we're building several APIs like a hydrologic location API. Right now we have the a river forecast API. Stream observation APIs named it, right? There are so many APIs that we are reaching right now. A lot of these APIs are only used for our internal uses right now, but the expectation is we want to make these APIs available to the public as well as we migrate to the cloud, right? So one of the things right now I'm very excited about, two data sets, especially analysis of record calibration to the AORC data. This is the data set that we have right now available into the RDAP API. Right now, what we're trying to do is basically we're chunking the whole the data. Originally, the data set is in the NetCDF. So what we're doing is actually collaborating with the USGS on chunking some data into a jar, right? And the ones that data is, we just finished the chunking that data sets, and we're in the process of making that data available through our NOAA Open Data Program node. And another work that we're working right now in the hydrologic ensemble forecast systems API, that's actually on progress as we're building that API, and that API is also going to be available through our National Water Protection Service as well. So definitely please look out for that as well. And very quickly, I'll keep it short that we have enough time. Oh, that's great. So we have enough time to discuss, right? But some of this is quick sort of architecture about our internal APIs, right? So we have a National Water API. That API is built on the Python. Basically, what that does is it's just a Python script basically parses your NetCDF files and pulls the relevant data back into the Postgres database, which is served through the Django API. Right. And another also we have, I talked about the RFC, the forecast observed API. That's also basically the same, but it uses the Python scripts to parse, but it parses the HTML files into the Postgres and uses the Django API as well, right? And similarly, for location API as well, this is a Java application. Basically, we pull the data from the NRLDB database and USGS into the Postgres database so that we can make it available to our internal users. So for all of our API, our primary users, like I said, our operation division, double pod, and evaluation division as right now. But we are trying to migrate that API available to the public as well at the same time. This is just a quick, I talked about, this is something I'm excited about. This is the API, we are building it right now, right? And this is going to be a game changer for our users because the HEFS is a pretty large data sets, and it's basically, what we have done is basically written as a microservice, as a cloud native application. And it's a build, like I said, basically built on the open API specs, and basically that is in compliance with our OGC standards as well. So just to give you a quick on that, this is like an input from HEFS and SAML forecast that is in XML format, and then the data output format is now the JSON. So, but we're expecting to have that also available as XML, CSV, and the NetCDF as the output as well for this API. Just a quick, this is my last slide. Some of the work that we're doing on the, like I talked about, National Water Prediction Service, we wanted to make sure that we have the water.noaa.gov or the National Water Prediction Service is going to be one-stop shop for all the hydrologic information that we provide, right? Because that's one of the challenges I hear from all the users. I don't know where to find your data sets, right? I have to go 3 different places to find the data sets. So this is our effort to make our hydrologic data dissemination a lot more accessible, interoperable, and definitely I want to make sure it follows our FAIR data principles, right? That's something in mind when we're building this capabilities. So some of those things, like I talked about, like, AORC data sets, definitely on chunking. I definitely would like to give a shout out to Rich from the USGS for helping us on some of the chunking of data sets, and Chris as well, I see from Open Data, who has helped quite up this effort here as well. So, and once that our AORC data set is now in the process of making it available to the data dissemination to the open data, no open data dissemination NOD program and hydro visualization infrastructure. I'm happy to take any questions. Please reach out. But one thing I definitely would like to say, this is something we're expecting feedback from you. You are our community, and we'll really appreciate the feedback that we get. And we also put through some of, I definitely would like to acknowledge some of my team, like Orion, who building the applications, and also our weather service, NCO. Just recently this week, actually, there is a restructure happened. So there is it's not like NCO, there's a new name came out. I don't remember, but there is a new name for that. So we have Office of Dissemination, as well as all the field offices that actually help to build this National Water Prediction Service. You can take a quick, look at the QR code. We actually put it sort of like a story map that talks about some of the work that we're doing on the story map about the National Water Prediction Service as well. So with that, thank you.
Thank you so much, Sudhir. So impressive, the work that NOAA is doing to make our data accessible. Thank you. I do want to mention, Teddy suggested that we address how questions will be addressed later at the end of our session. We do understand that there are some questions that are coming in to Mentimeter. So I do suggest that Susan and Sudhir, please, and speakers do take a look at those Mentimeter Q&As. You can access those by your phone as well. And that tees me up to Dr. Mike Humber, who I was introduced to by Kim Locke in advance of the commodity class of work that Applied Sciences is doing in advance of working with farmers and the agricultural community. And I am continuously impressed by Dr. Mike Humber of the University of Maryland. Recently asked to serve as deputy director of the brand new NASA Acres, which I think is a acronym for something, but I don't know what it is. I'm so sorry. It's a failure on my end, but it is the Domestic Consortium for Agriculture. And this guy is very impressive. And he's not going to be talking about the remote sensing work that he has done with his team on the Ukraine on agriculture. But I do recommend, if you have some time with Mike, definitely talk to him about it. He gave a hyperwall at a couple of different events, and it is just the research is stunning, sad, but it's remarkable. And so as we're teeing that up, yes. Oh, so, and that does remind me. So please at this time, go back into the Mentimeter polls. We do have 2 of those questions for you to add any words or phrases that come to mind about problems and pain points, as well as solutions. I think Sudhir gave us lots of solutions that NOAA is developing and prototyping and testing. So, all right. So I'm excited. So Dr. Mike, what does ACRES stand for?
Acres. Acres used to be a fantastic acronym, and it's now just the word acres. for
God, I'm off the hook.
Yep. Yeah.
All right.
That's it. Okay. Thanks for having me here. I'm sure Elizabeth was saying nice things in the background, but I was fiddling with PowerPoint here. Very happy to be here, and thank you all for the invite. I'm really excited to talk about some of the work that we're doing with our systems that are really designed to bring in users that are not traditionally from the agricultural remote sensing community into the type of work that we do, and being able to use primarily NASA, but also other Earth observations data for doing their analysis and bringing that into their own systems. So as was mentioned, I'm Mike Humber from the University of Maryland, also working with NASA Acres and NASA Harvest, which are NASA's consortium on food security and agriculture, both domestically and internationally. This is actually a presentation about a software that we've been working with for about 15 years at this point. We did a major overhaul of it a few years ago, which was kindly sponsored by ESDIS actually. And a lot of what we've done is modernize that in order to bring in more tools into the system so that people can use this with actually very little expertise coming into the system. So that's why I've titled this from novice to expert. We're really trying to cater to the needs of the user who really has no experience with this data, all the way up to the needs of the agricultural remote sensing expert that really knows how to tease the specific details out of this type of data. So just to briefly start, what I'm talking about is what we call the Global Agricultural Monitoring System. This is a system that we've actually been running for, like I said, 15 years, originally developed in collaboration with the Foreign Ag Service of the USDA. And really the goal behind this is to provide free access to near real-time data for monitoring agriculture conditions across the globe. Our main sort of drivers or main data sets that we use here are the MODIS and VIIRS NRT vegetation products. So primarily NDVI, but also the NTWI, which we supplemented with soil moisture, temperature, and rainfall from a number of different sources. I mentioned before that this is really meant to be used by both specialists and non-specialists. What we're trying to do is take a lot of that data computation burden off of the user, do it in our system, and allow them to focus on the results. So what we're trying to achieve is reduce the time it takes to get the data from the satellite, bring it into your system, do your analysis, see are things good or are things bad, and then bring that into your own system, whether that's in the form of graphics or CSV files, things that will give you the idea of what the time series actually looks like. So currently this is hosted by NASA Harvest, which is their consortium on food security and agriculture. But this is actually, that used to be a little more meaningful back when it was hosted on premises. Now this is all in the cloud. So this is what our system looks like. I'll put a link up later on if you want to go ahead and check it out, or it's just glam.nasaharvest.org if you want to jump ahead of me here. And what we're providing here is a way that users can get into this web map and visualize the data, whether that's the actual current value or the anomaly. So how is this condition relative to the normal conditions, and how does it compare to previous years? We allow the users to mask the, in this case, NDVI data or any of our data sets by the crop type. So we can say, show me only the areas that have spring planted wheat, winter planted wheat, corn, soybeans, so on and so forth. And we can do that on the fly. We allow the users to show the anomalies. That's actually what we're looking at here. So this is a relatively recent map where we can see where the crops or the vegetation in general is doing poorly versus doing well. And we provide some statistics calculations tools for this so you can see what the mean, max, min values are for whatever area that you're interested in. We allow the users to export these graphics so they can put them into their own reports or bring the data into their own systems. And then it's covered by the arrows here, but we also have a data API so you can make these requests over any sort of curl or whatever other type of web request library you want to use. So the main classes of users we are targeting, we're really kind of designing with these two main groups in mind, but really it's kind of everything in the middle as well too. So the people that we're really mainly targeting primarily are these non-specialists, or you can call them whatever you want, novice users, general public users. These are people that have an interest in the data, but don't necessarily have the training and the expertise to extract the maximum value out of that data. They just want to get a very brief view of, are things good, are things bad? And these are the users that when we think about what this user does, typically they're going to rely on the default settings. And that puts a bit of the onus on us to make sure that the default settings are appropriate and give a reasonable result. We don't want to use a default setting that's going to give really kind of wacky results that are irrelevant. We want to make sure that if the user cares about, we don't want to be showing them the NDVI of water, for example. Oftentimes these users are also, because they're a little bit less technical, they're not going to download this data, ingest it into their own system, create their own graphics. So for this type of user, we're actually trying to provide presentation ready graphics to the extent that that's possible. On the opposite end, we have the sort of trained analysts, the agricultural remote sensing experts. And of course, they're typically going to have a little bit more technical capacity, not only for understanding the data, but also for doing analysis and programming and bringing that into their own systems as well. These are the ones that are going to lean more on that advanced functionality. So going with specific season crop type maps to mask out the undesirable areas. They might be more into adjusting the cloud tolerance. So we have a threshold that we can say, ignore any data if we have more than 25% cloud cover all the way up to 100% cloud cover. And they might even want to change the compositing window. So with these users might realize that the way that corn is grown, for example, in this region has changed significantly over the last 5 years. So I don't want to compare this to the 20 years before that. I just want to focus on the last 5 years. And that's the type of user that can bring that expertise into the analysis. Typically, when you think about these users, they might actually access the data through our API rather than through the web map. So they might be using Python, R, or other tools and actually reaching out to our API that we document using Swagger and then bring that data as a CSV into their own proprietary systems. So, in brief here, the tools need to be useful to the non-expert user by default, but also flexible enough to accomplish what the analysis of the expert user is. So we want to try to accommodate both sides of that, those questions there. So all of that in mind, the design goals of the system, first of all, we have to visualize and analyze the data. That's sort of the non-negotiable part. But the part where we bring a little bit more value is also bringing in the near real-time visualization and ingest capabilities. Historical context, I think, is one that's incredibly important because historical context really makes the analysis much easier. If you don't necessarily need to know that a NDVI 0.7 corresponds to whatever amount of yield. If you can look at this year, look at last year's NDVI and say, okay, this is higher than last year. So it's probably a better sign than what we saw unfolding last year. So we allow users to do that both as a time series, just looking at the values over time, but also in our customizable anomalies and our year-to-year differences. So we have this concept of analog years where we can see that, we know this year sort of shaped up similar to 2012. Let's compare these two directly. On the visualization side, we try to simplify the interpretation. So we use color scales that make sense. Green is healthy, brown is bad when it comes to vegetation, hot for red, cold for blue, so on and so forth. And again, those default settings really saving the more powerful settings for the advanced users, but also making it useful to the non-experts. So here are a couple of different types of users that we have. These are, I would call them partners more than users because we've been working with a lot of these groups for so long. So this is Conab from Brazil. This is a public company looking at agricultural conditions around Brazil. And actually, they're one of our most steady users of the GLAM system over the year. And you can see actually the figures on the left here, these are pulled directly out of the GLAM system. And then these get published into their monthly bulletin that they put out on the conditions of crops in the entire country. This is actually a customized version of the GLAM system that we put together with them. So on the left-hand side here, you can see the map. This is actually masked by their crop map, their soy map that they gave us to bring into the system. And we're able to bring these in, combine them with our data, and actually use their crop regions combined with the NDVI data to highlight specifically those areas where they want to focus their analysis. We're also able to bring in the custom sort of zones that they use in order to define their agricultural regions. On the top right here, you can see a graph of the vegetation index that they pulled into their reports. And then the bottom right here, we have our monthly snapshot. So this is showing us for 4 of the main Earth observations data types, the precipitation, soil, water, and DWI and NDVI, how those are unfolding throughout the season. It gives you a quick overview of what those conditions look like. This is another example. This is from the Bolsa de Cereales de Buenos Aires in Argentina. Esteban Capati was the head of agricultural estimations in the Bolsa, and this was actually some analysis he did using the GLAM system in 2020. Looking at a drought that was unfolding. It was actually pretty severe drought and impacted a lot of the production in that region. And the reason I highlight this is that Esteban and his group are actually agricultural economists. They're not remote sensing experts. They're not trained in how to use this data from the agricultural Earth observations perspective, but they're able to pull in this data and look at the graphs, understand what's happening. And actually, I didn't post the whole thing, but there's some comments on here where the farmers are saying, actually, that makes a lot of sense. That corresponds very well to what I'm seeing in my fields. So this is an example of how we can use this data, even though it's a lot of data that we're pulling in and number crunching and all of that sort of thing, to reach out to people that are not going to be super technical, users with the ability to process this data on their own, but they still gain value out of the system. And then one more example here. This is the geogram crop monitor. This has been around for quite some time. Going back to around 2013. This is actually one where we use our data API to pull some data from the GLAM system into this other system here. And these are used to inform reports that go into a monthly bulletin that's used to give an idea of what the crop conditions are around the world, to give an idea of global supply. And these users are actually economists, and it's more of a general readership. These are people that do not work with satellite data really at all. I have a note here that economists don't like maps. We try not to hold that against them anymore, but they'd rather see it in a spreadsheet. So what we've done is we found a way to take this data and distill it into something that's nice and easy to read. And once it's in that format, it's a little bit more digestible, a little more understandable, something you can just look at, get an idea of what it is, and get your answer out of it. So I'll quickly talk about how it works. I think Cedar had done a nice overview of how they've done their cloud transition, so I'll talk a little bit about mine. Our main goal is to make sure that our system is operational. So when I say operational, I'm using the textbook definition here, in or ready for use. And this means that, practically speaking, our archive needs to be updated as soon as new data becomes available in order to make sure that we're giving the most recent information possible. That also means that our tools need to be able to visualize, analyze, and provide download access to that data as well in near real time. So from the user perspective, if you were to do this on your own, there is this sort of workflow that is itself the barrier to entry. You have to download the NRT products, you have to process those. Then once the standard product is available 2 days later, you download that, process that, replace the NRT with the standard product. And then on top of that, you have to do all of your statistics and mapping on the fly. So this is sort of an older diagram, but this is kind of how our workflow originally was, where we have the near real time system. We're bringing in the daily near real time surface reflectance data. We process that into our NDVI composites. And then once the standard MODIS product's available, we bring that in. We replace the near real time product with the standard product, because we get about 2% improvement in terms of accuracy with the product there. And then all of this gets constantly ingested into the web interface. Around 2018, we actually were asked by ESDIS to do a little bit of a demo of what it would take to shift an operational product into the cloud. So we actually took our cluster, which is this guy on the right here, this 3-node cluster here, and tried to transition that workflow into the cloud. And we did a little bit of analysis. We looked at the lift and shift model and found that was going to cost several $1 million over the course of a couple months. So that was sort of a non-starter, and we ended up going with a more cloud native workflow. And what we're really doing is trying to replace this original workflow here, where on premises, we're downloading all the data, we're calculating the means, differences, anomalies for each of the products. And we're doing all of this in a sort of multiplicative way, so that every time we get new data, we multiply the crop maps by the number of products that we have, by the number of regions that we have, and then we cached all of that and stored it locally. And what this meant from a system perspective is that we had a very large data footprint. We had about 300 terabytes of data that we were sitting on in order to make this happen. And that's obviously not something that you're going to ask a user to do. They'll spend months and months and months just downloading data. So instead, we looked at these cloud native solutions. 1 minute, wow, okay. we ended up with a workflow that actually lets us do all this stuff on the fly. So we've gone from 300 terabytes down to 10 terabytes of data. And that brings us to a break-even point about 37 years. And just for reference, because I like historical context, the state of the art 40 years ago was this Commodore 64. So I'm not too worried about what happens in 40 years as far as our cloud system goes. So I think that my GIFs are actually not working here. That's too bad. These were GIFs showing you exactly how the system works and what it looks like. So instead, what I'll leave you with is I'll actually skip ahead here to our access page. So if you want to check out the system and create your own GIFs, you can go to glam.nasahours.org. We also have the stats and visualization engines up on GitHub. This is a relatively new repo that we just put out there. And the takeaways of this really are that interpreting this data is not trivial. So what we want to do is provide tools that we can use to help the user by giving them options that are customizable to their skill level and what they're comfortable with doing in terms of analysis. We try to do this by providing historical context so that the analysis becomes, is this good or bad, high or low, rather than understanding what specific values mean. We try to remove the need for complex programming workflows, don't give the user 300 terabytes of data, obviously. And then from there, we try to enable the user to export those results and share further analysis. So you can actually link to, you can permalink to your analysis and send someone a link to a URL and they can open up the exact analysis that you were working on from the system. So all that said, thank you. Hope I'm close enough to on time.
Thank you so much. I appreciate it, Mike. All right, so now we need to Daniel. So we're going to transition over. No. You're going to introduce Daniel? And Daniel is joining us virtually, is that right?
Yes.
Yes, all right. So thank you so much. Give us 1 second, Daniel. So at this time, go ahead and put in your comments in the Mentimeter about pain points, problems, as well as solutions that Mike has presented. The GLAM tool is fantastic.
Ready? Okay. Hi, everyone. It's my pleasure to introduce Dr. Daniel Tong. Dr. Tong is an associate professor in the atmospheric, oceanic, and earth sciences department at the George Mason University. Professor Tong is a associate director of the Center of Spatial Information Science and Systems, also at the George Mason University. He was elected as a president-elect of the GeoHealth section of the AGU in 2022. And he will become the president of the GeoHealth section for the 2025 to 2026 term. Okay, Daniel, the floor is yours.
Thank you, Tom. Are you going to run the slides or you want me to run it? I can share my screen if you give me the permission.
I think she can, he can share.
He is.
Okay, all right, awesome.
Okay, and he's going to share his screen. Okay, perfect.
Okay. All right, hello, everyone. It's really nice to have the opportunity to present here. I'm sorry I could not join you in person. I very much look forward to the next time. So this is really a talk that's different from the rest in that I'm mostly focused on a user lead, trying to present a problem faced by our society and our troubles, how to address those problems. So hopefully we'll give some idea about the future directions of data services and how we can work together. This is really an effort of a very large team involved, people at Mason, UTAP, Free University of Berlin, USDA, with a lot of funding and other data support from NASA and also under the coordination of WMO. So as climate change and the Earth get warmer, we are seeing a lot of problems such as the Canadian fires right now, and that's coming all the way to the Western US and also to the Eastern United States. A few days ago, DC got the worst air quality in the entire world, which is something we have never seen since the 1930s during the Dust Bowl. Another problem being overlooked is the dust problem. As I mentioned earlier, during the 1930s, we have this environmental catastrophe called Dust Bowl that's really destroyed the entire agriculture and ecosystem in the central United States. And people was having very hard time for 20 or 30 years in that region. So is that another Dust Bowl coming or not? It's been something hotly debated in the academic community. So since a few years ago, I have studied with NASA funding supports, look at the trend of dust storms in the Western United States. We started with a modest dust detection and then use the satellite data to train a dust detection algorithm. Combine that with the ground monitoring data, we come up with a long-term trend. What we found was very surprising in that the US dust storm frequency has been increasing about 12% per year in the past 20 years, which is 10 times faster and in the opposite direction of the global trend. And our effort was only part of a big efforts by the community that's showing that increased the dust in the rainwater, in the dust deposition on slope in Colorado Mountain, and fine soil in the air. So there's a lot of research been going on trying to figure out the trend, and we expect this as the drought to become more severe, we're going to see more dust storms. So a problem with the dust storm in the United States and also in the entire Pan America region is that a special fungus living in the soil in our region. It's called coccidioides. This fungus, if it's undisturbed by the environment, it's going to be there and grow. It's something like a mold, and it's going to break, go back to life again. But once the spores of the fungus was inhaled by human or animals, it's got unlimited supply of moist and nutrient. So it's going to rapidly grow. In 1 or 2 weeks, it could convert your lungs into a big mushroom. And then also because the size of the spores is very small, it can flow with blood, go to a brain. So 2019, I was attending a meeting in Phoenix. On my way home, I talked to the Uber driver. I said, do you know valley fever? He said, of course, my daughter recovered from valley fever just a few weeks ago, and she lost her memory because the fungus just flew into her brain, and that part of her brain was in control of knowledge that related. So she had to retrain herself for her old job when she got back. It can grow out of your skin. It's really nasty. Because the fungus lives in the soil, right? So one question we're asking is there any correlation between dust storm frequency and the valley fever infection? And we put the dust data, which is the red dots on the left, together with the valley fever cases from CDC, which is the background, the foreground, the background color. The darker the color is, the more cases. You can see that those valley fever cases are mostly found in the same region that's frequented by dust storms. And we also look into 2 endemic regions, and that's Maricopa County in Arizona and Pima County, Arizona. And only in the dust storms that's close to the city centers has a stronger correlation. So it's pretty much like a local dust storms causing a higher infection. In the United States, I just want to mention that right now we have more than 4,000 people already killed by dust storm, by valley fever. And then there's hundreds of thousands or more. It's very costly. It's costing about $4 billion per year just for this single problem alone. And right now we know very little about it. Even we have this correlation, but the physical and the biological processes and connecting dust storm and valley fever is still unknown. So the other problem we are having with dust storm is highway safety, right? I wish you have never been driving into a dust storm. There's really little you can do about it. You lose visibility. You can stop, but people can hit you from behind, or you keep driving, you hit others. So that's a lot of problems in the United States caused by the visibility problem during the dust storms. And because the desert land is relatively cheap, we are also seeing a lot of solar farms being set up in the desert. And once the solar panels are covered by dust particles, it can significantly reduce the productivity of those solar farms. So I will be able to just have time for a few examples I will give to you. Just a few weeks ago, I spent almost the entire month of May doing interviews with the media for the dust accident on May 1st, 2023, on Highway I-50 in Illinois. So basically what happened is, Illinois was very dry in April, much drier than previously. So once farmers till the land and there's a strong wind coming in, they generate a dust storm. The people in that region are not educated by the risk of dust storms, and they don't know how to deal with this. So they have 8 people killed by dust storms, by that dust storm, 37 hospitalized, and then 72 cars piled up just in a single accident. And this is not unknown. We have the worst one was in California in 1991. We also have a similar 8 deaths accident. We should not call it accident, it's really crash in Utah. And there's 7 and 6 deaths in 2 accidents in New Mexico. That's in Noblesburg. It's the same location. You can show it on the lower right. So the challenge for us is those dust storms, originated from the farms, and it's not traditional desert area. Most of the models are able to even describe the mechanism or the source region. So something that we really want to achieve from using satellite data is to detect land disturbance in real time, right? For example, if a farm is tilling land in a very dry region, and we really be careful about that, because when there's a strong wind, it's almost a recipe for disaster. So that's actually, it's very relatively, little known by the American public, how many people are killed by dust storms, right? If you look at the National Weather Service data, they report 1 death on average, 1 death per year in the past 20 years. And if you look at the media reports, you can see that in 1 case, can have 8 people die, right? So this is, the math just does not add up. What we did is we look into 3 data sets. One is the NOAA Natural Hazard Statistics, which is the one being widely used, including in lawsuit. People are using that information by the media as well. The other one is NOAA's storm events data, which is citizen science sort of data collection mechanism that everybody report that to NOAA, and NOAA have a database running back to 1950s. And the third one, I think is relatively less known, is the police accident report. So every time you have a fatal accident, that's going to people are going to file a police report. So we have an intern working in our lab for 2 summers, just look into all the police report, and we combine the 3 data sets together. We found that there were about between 14 to 33 deaths every year caused by dust storms, which is 20 times higher than what is currently known, reported by the National Weather Service. There are 2, so some are from the desert, like southwestern US, you are very familiar with, and some actually from these unconventional sources, such as agricultural land. This is one example in 2009 over the Colorado Plateau between Washington and Oregon. And we also have 2 very dangerous hotspots. One is 10 miles between Phoenix and Tucson, called that is 10 miles. Between the 10 miles on Highway 10, we have hundreds of accidents caused by dust storms. And the other one is Noblesburg, Playa. Playa is a dry lake. It's between New Mexico and Arizona. It's caused by several large dust storms I presented earlier. So about 60% of the most deadliest accident happen along Highway 10. So make Highway 10 the most dangerous highway to drive during a dust storm in the United States. So we are covered valley fever, we covered transportation safety, but there's a bunch of other things that's also cause problems for the local communities. such as animal disease, dogs, horses, and even sea animals can cause the same problem by dust storms. And then also aviation safety. Right now, the engine is getting much hotter because of new technology. So the engine can directly melt dust right now, just like it's melt avocado ash. So dust will become glass attached to the turbines. That's going to cause permanent damage to the engine. Yeah, a very dangerous risk right now for aviation. And we also have a marine navigation problems because of visibility and strong wind. Solar energy, we have harmful algal blooms, and it's also causing water contamination, food contamination, and it's going to import the microbes into the cities. In some parts of the desert, there's actually heavy metal contamination is a big problem, such as salt and seeds in South California. And also because we have this historical nuclear test site, so sometimes it brings radioactive contamination to the city if it's blown from that region. So this is an effort by the WMO and the WHO with 28 experts working together. We just have this huge review paper published on review of geophysics. If you're interested, you can check it out. So to address this problem, now it's a global initiative because I chair the WMO research program on silent dust storms. So with WMO's help, now we have assembled a large team of centers around the globe trying to come up with a community consensus of global dust emissions, concentration, vertical profile, optical depths, and deposition from 2003 and on. That's we call it satellite arrow Moody's data sets. So we have 3 phases, and it's going to first select a few centers to participate in this global reanalysis. And then we're going to do downscaling, machine learning, come up with the phase 2, the new global products. And then phase 3 will be develop service products for public health, agricultural, transportation, renewable energy, and so on. So I want to wrap up my talk with just some thoughts on the challenges we have to address those societal problems, especially related to the dust, to the data needs, for dust storms research. And the first problem is dust source rigging, right? So I mentioned earlier, this most dangerous killer dust storms actually caused by sources that not in the desert, but in temporary sources such as farms. So how do we detect that? If you have a real-time solution for detecting land churning, for example, please let me know. I will be very happy to work with you on that. And we also have a problem with getting weather and climate condition data sets, including soil moisture, sea surface temperature, and to a next problem with climate indices. The most striking problem right now is we don't have a proper soil moisture product. We want a 0.1 centimeter top layer, but now we are unable to get that data sets because the soil moisture data sets are not suitable for dust detection, dust forecast. The other one is the dust detection, right? So satellite are unable to detect most of the smaller killer dust storms, which I hope with Temple and the newer sensors, we will get some better results, but it has a way to see. Okay, so I will end my talk here. Thank you very much for your attention.
All right, at this time, if you have any space left to enter any words or statements about the problems and solutions, go ahead and do that now. Yeah, that's great. That's great. So as we look at some of the cumulative entries that we have, some of the, you can see that this one's actually pretty divergent here with in terms of the pain points and. Oh, yeah, no problem. And we don't have a lot of time for this, so we're going to make it pretty fast. You can see here, I'm not going to read over each of them, but actually I'm seeing some of the keywords that you guys each identified yourself as, which is kind of fun. But you can see what I am actually, let's hear from you. When you see this huge word cloud, what kind of inference can you make based on this word cloud about pain points and problems? There are lots of them, right? Right. Yeah. And even like the convergent ones, that text, that font size is pretty small, right? So that's interesting. Let's see here. All right, let me go. Thank you. All right, thanks. In terms of solutions, so what inferences can we make about the solutions?
Training, documentation.
All right, what can we, come on, guys. I mean, it's not quite lunchtime. I mean, it is lunchtime. It is lunchtime. I mean, we're squeezing out just a little bit more time. All right, so do we have a few solutions or lots of solutions? Okay, fewer. Okay, right. But there's still there seems to be a lot of solutions here. Documentation seems to be pretty key. Metadata training is something. Hey, and this is a pitch for our later session at 2:00. We've got a session with the great Jennifer Brennan back here and Ross, where we're going to be doing some introductory training to NASA resources. I'm pretty excited about. So check us out. Let's go ahead and see here. We'll return to that. I think we have, so we heard here in terms of, all right, some other solutions, chunking, cloud skills, tooling, interoperability, mobile friendly. We heard that before. Going through here, seeing if there are any other customize, knowledge. All right. Okay, so here is another question that we had for you. If you have ideas for next year's interdisciplinary needs ESIP session, we would love to hear it from you. So take this time. So far, we have one response, but we have more than just this one. Thank you to that one person. Tooling and training examples to upskill research. If you have other ideas, and maybe you're a presenter and you're like, hey, you were in your jam giving a presentation, you're like, gosh, I wish I included that slide about blah, blah, blah. You know, like if that was you, put it in there, submit that as like a follow on to something that maybe came to mind. Would love to hear from you about that. But I am not going to belabor this. We have tons of questions from our audience, whether they be online or whether they be a back channel from you here in the audience. And Zong is going to lead that. We've got Shruti here, then she's going to bring up the document, and Zong's going to lead us in that quick discussion in the whopping 7 minutes that we have left. This document. And so these questions and answers are accessible to you. So speakers, if you have not had a chance to take a look at this document, Teddy online, thank you, Teddy. We love you, Teddy, has gone through here and identified the question and the the presenter, I believe, and the attendee who asked this question. Please take a moment to review them and maybe write an answer. If you've got a moment, that would be great.
Okay, so any questions from the audience? For the speakers and discussion?
I think this is a great discussion and presentation from all the speakers. And I don't have a question, but I do have a comment based on the Mentimeter that Elizabeth just rolled it out. The funny questions, the observation I saw is, you know, the biggest found in the very first question is, what is the challenge, you know, that you think from the interdisciplinary wise, and is it documentation? And the second question that you ask is, what would be the solution? It's also documentation. So, I think it's very interesting, but, documentation definitely is the key, but I don't think the solution, I have not seen any good solution. As you can see, interdisciplinary users and different user journey and what they want is different. So how can we put out what I wrote it down is a fitness for usage for specific users. For that kind of documentation, I don't know what would be the best solution.
I want to add another flip side of this. We are emphasized on the data provider side or this data distribution side. The user side, you're talking about training, that's extremely important. Giving you a simple example. First time I went to an Italian restaurant, I don't know what to order. What problem is that? That's my problem. That's not the restaurant problem. So we need to see both sides. Thank you.
Don't go to the restaurant then.
Any more questions? Oh, yeah, okay. Yeah.
Okay, so this question, or a couple of questions for Susan. Were the workshops, the Unbound workshops, virtual or in person? And if so, did it cover for the travel cost of attendees? And was it based on a flat amount or a person's salary? And
I apologize. I'm having a hard time getting into the Google Doc and editing on my phone. So I can cruise through a couple of those. They were all virtual. The stipends we provided were flat stipends. They were $2,000 per organization. And we left it to the organization. If they wanted the money to go to the individual, we'd pay the individual. If they wanted it to go to the organization, we paid the organization. We chose the organizations. We tried to go to their networks. Right. We tried to find environmental justice listservs and groups and meetings and get in there and get the word out to recruit. And we had them fill out an application form. Same thing with air quality. We had some great opportunities at AGU to engage with people who are working in air quality. How we selected them. We first looked for were they using NASA data currently? If they were a NASA data super user, like, thank you, no, thank you, keep on trucking. We wanted people that were not using NASA data or not currently using NASA data. The next screening point was we ask a few questions to understand how comfortable are you using data and what types of data do you use? If they are just using spreadsheets in Excel, we kind of said, oh, I don't think they're going to get as deep as we want to go. Then we looked at, well, what are their key research questions? And we talked with our NASA partners and we said, do you have data sets that can answer this person's research question? Or is that going to be fruitless? And once we kind of identified those things, then we looked for geographic diversity and type of organization diversity and individual diversity as best as we could. I think that was most of the questions. The one question about the format, I am not the person to answer why they liked that one format.
Can I just ask a quick follow-up, Susan? How many did you lose at that you were only working with spreadsheets?
All right, Mike, can't remember.
Hi, Jim Call from Linker. Susan, just a real quick question. How hard was, or how many did you lose at that lower end of the technical scale?
Great question. It kind of feeds into one of the other ones I saw in there. With the environmental justice stakeholders, we lost a ton. We lost a ton. They did not have the people on staff that can manipulate data in the way that people in this meeting are used to seeing. And that was frustrating and hard. And we had hard conversations in the room where they just said they were brutally honest. I mean, the good thing about the environmental justice community, they don't hold back. And they're going to tell you, come on, NASA, I don't get this. I'm mad, I'm frustrated, so they really spoke up. The air quality group, we really had to purposefully look for people that had a little bit higher. So someone asked in the design, we learned a lot from environmental justice to air quality, and air quality was much more guided. Like you saw, the first exercise we said was go download, go find this specific thing. And that type of workshop design was more successful at getting specific feedback. Where the environmental justice one, we had people trying to solve all different kinds of problems, and it was just a lot of herding cats.
So I'm gonna add one more point. So Susan, you said about the whatever that working group, actually within NASA, with a gray hair group, there's quite a few, you're gonna lose them if you talk about HDF or NASCDF in the science directory.
All right, it is 12:30. We've got. There's one more for Susan.
So sorry, Susan, one more for you. Would you change anything next year, depending on what responses you've got for your workshop this?
Yeah, this was a discrete activity. I don't know that I don't know what the future plan is. I know that Unbound itself works with other organizations, including they're looking at citizen science groups and indigenous groups, and ESIP may or may not be the right people to do that. But if we did a similar activity again, like I said, the more structured approach that we took in the second workshop series, I would continue to look for that.
All right, I believe we do have an Unbound series that is starting up on coastal resiliency. So please keep posted on that. And I do want to do a pitch that our team has taken the Unbound air quality report and used some of the action items and have updated that data pathfinder for air quality. And we released that thanks to Josh's help as well as Teddy online to update that. And we released it on Monday. So I will be giving a poster, and I want to say Jennifer helped it out tremendously as well, and making sure, and a lot of the DAC. So I don't want to forget that. So to make sure that we're including the data that the DACs want to promote as well as the tools. But we do have resources for a variety of different end users. And so please do come and check out our poster tonight. But it has been a blessing to work with you all. And please stop by and introduce yourselves and come by our session today from 2 to 3:30. If you're new to NASA data and tools, we would love to work with you and get to know you.
With that, thank you, everyone.